Hello there, this is exercise 1B.5 for discrete maths again, A-level further maths for OCR. And one particular thing they have on the OCR board is they have this thing called derangements. And derangements are like, I suppose, the opposite of arrangements, or at least partly. The derangements are where you have a bunch of things. I mean, the picture's got 4 letters, but they all end up in the wrong place, all of them. And that's a derangement where everything's completely wrong. So you notice I've got 4 here. It's meant to be 4 envelopes, 4 letters. And in each case, the letter isn't where it's meant to be. That is an example of a derangement. And we are meant to be able to do for OCR maths, we are meant to be able to count these derangements. So if I just go on to the next slide, it basically says that like a derangement is a special type of permutation where it means basically arranging the objects is done such that none of them are in the original or correct position. That's the idea. That's what we're looking for. And it's helpful to know if you know what the standard values for these derangements actually are. And there are basically ones that you're meant to know. For instance, if you have one item, it's basically impossible to get that wrong. You've got one item, one place to put it, it's going in the wrong place. So there's no derangements. If you have 2 items, I've written here A and B. Now, obviously, if I have A and B, there's my pen. So I could have A and B, and I could have B and A. And so by definition, one of them's right, one of them's wrong, and therefore there's one derangement. If I had 3 letters, let's just go to 3 letters, A, B, and C. Now imagine that's the correct position. I could, I suppose, put them in A, C, B, but it does say that none of them are in the right position, so that's not a derangement. What would a derangement look like? It would look like, or B, CA, for instance. That would be a derangement. What else would there be? Well, I could, I suppose, have C there, I could have A there, and I could have B there. That would be a derangement. And you quickly start wondering to yourself, how many might there be of this? And it turns out, when you have 3 things, there are only 2 derangements. As I found there, I know I could have carried on finding them, and it is helpful if you know these derangement lists, and like just the standard ones just off by heart. So for instance, knowing that 4 items can be deranged 9 times, or 5 is 44, and eventually, of course, you're not expected to learn all these, but it's just helpful if you know a few of them. This, by the way, is sometimes written as D4. So D4, derangements with 4 items, would equal 9. And there you go. And the OCR board isn't too bothered about how you get your answers. You might be asked to list them, like I've started doing there. You might be asked for an exact number. So here is a question, and it says 6 letters are placed randomly into 6 correctly addressed envelopes. Find the number of ways in which none of the this is it. This is a derangement, then, isn't it? Now, this deliberately is actually me trying to make it a bit more complicated. If I had said 5 letters, we could have just quoted the answer from the previous page. 5 letters would have been 44. So there must be lots of different ways, to get the 6th. What is that number there? And that's really what we're doing. So if we're going to do this question, we've got to go back to basics. If I'm not going to just cheat effectively and learn this answer, and it may well say show how you're going to do it anyway, so I think I've definitely got to do this properly. I want to show you how to do that, and the idea is we're going to eventually use the inclusion-exclusion principle, but for now we're just going to say how many different ways could I arrange them in the first place, and this is for part 1. And I could say there's 6 letters, so therefore 6 factorial ways of doing it. And if I type into my calculator, I get 720. So start off on that premise. And then what we've got to do is say, well, I want the ones which are none of them in the right place. Now, I suppose what I can do effectively is take them away from this number, bearing in mind the inclusion-exclusion principle. So what if I say that I could get one of these correct? And if one's correct, effectively that means from that one correct, I could choose any of the 6 envelopes to be correct. So that's 6C1. and that equals quite obviously 6. But there's 5 other letters in there, 5 other letters to be placed, and therefore they can be arranged in a variety of different ways. So I've written 5 factorial, and if you do 5 factorial, again, there is a good thing about the calculator. There is a factorial button. You can type that in. You get 6 times 120 different ways in total. That's 720. Then I'd say, well, I could have got 2 correct. In the same way, I can go, well, there's 6C2 ways of choosing those. 6C2 is 15 on your calculator. And again, that leaves 4 that are incorrect. And they can be placed anywhere. 4 factorial is 24. And again, I multiply these together to get the total number of ways to do these. 15 times 24 is 360. And then 3 correct. And again, there are 6 letters. I'm choosing 3 of them to be correct. 6C3, just remind myself what that is. That's 20. And that leaves 3 which are wrong. 3 factorial is 6, and 20 times 6 is 120. And this one I'm going to carry on doing 4 correct, which gives me 6C4. Nearly wrote it wrong. 6C4 again. Well, by symmetry, we know that's 15. And that means I've got 2 which are wrong. 2 factorial is 2. And 15 times 2 is 30. Carry on. What have we got? We got 5 could be correct. And that is 6C5. And again, that is equal to 6. And 6C5 leaves 1 factorial, and 1 factorial is just 1, so 6 times 1 is 6. And the last option to get these things all in the wrong place, so is to take away the 6 correct ones. But effectively, you can see this process leaves just all the others. Must be effectively the correct ones. So let me just do this. So what have we got? We got this time, we got 6C0, I suppose. We got 6C6, which is the same thing as 6C0, but the wrong way around. So which is 1, which leaves if I overly complicated this, I should just really write this. Oh, this is 0 factorial. 0 factorial is 1. There you go. 1 times 1 is 1. I knew the answer was going to be 1, but I just couldn't remember how to get it then. All right, and so look, this is the bit which is not obvious. So using the inclusion-exclusion principle. And we've seen that elsewhere, so I'm not going to spend time debating why this works. But basically what I can do is I can take my original 720 up here. And then I basically go take away the first answer. I add the second answer. I take away that 120. I add the 30. I take away the 6. I add the 1. And you just alternate them like that. And that disappears. 3, 6, that's 240, 270. And that's 5 effectively. I think the answer is 265. And that's not obvious at all, I think, but have a look back at the exclusion-exclusion principle if needed. Okay, now what's the next part say? It says find the number of ways in which exactly 2 letters are placed in the correct envelopes. All right, okay. So now this is, I'm going to cheat a bit here because this makes it now manageable in terms of what I'm expecting you to remember. So for part 2, to get 2 in the right place, so 2 correct, 4 must all be wrong. I suppose I can just say to myself here, okay then, those 2 correct, I can choose them in 6C2 ways. And the 4 wrong, I know they must be effectively D4. It's 4 derangements out of, how many different ways are there of deranging 4 things. So therefore, for my 6C2 is we had it up here. Where's 6E2? 6E2 is 15. And derangements for 9 was for 4 things from memory. Let's just go back and have a look at that. Let's have a look. There, it's gone in. Yeah, 4 is 9. That was what I said is very helpful for you who learn these things. And this is where it comes in handy. 15 times 9 is 135. And I'm straight there to my answer. I've not had to calculate that particularly. And again, if I'd remembered that, say, for instance, what was this? This was D6 things, was 265. I could have done that question without doing it. It just says, find the number of ways of doing this. And there might be a way, if just saying to yourself, I'm just going to learn these numbers. I'm going to learn that D4 is 9. D5, I remember was 44. D6 apparently is 265. We've just done it. So there you go. 265 and 135, they were the correct answers. 5 letters are placed in for a start, I'm already happy with this question because it looks like it's one I could just almost cheat with and just know the answers. 5 letters are placed in 5 addressed envelopes. Find the total number of possible arrangements. Well, it strikes me that that is 5 factorial. And 5 factorial, I should know that, is 120. I haven't got a calculator, so I'm having to look at a piece of paper to see what I've written down. And the next bit says, find the number of arrangements in which exactly 3 letters are placed in the correct envelopes. So I suppose we got our 5 envelopes, and we got exactly 3 of them in the right place. So it could be, for instance, B is, C is, and E is. They are all in the right place, but the other 2 are in the wrong place. So what do we have to do here? I suppose the obvious thing is, we've got of these 3 things, we could choose 5C3. We can choose which 3 letters are going to be in. It's not necessarily B, C, and E. So 5C3 I need to do. That's equal to 10. And then I've got the other 2. Now, I suppose with the other 2, they can't be right. They must be deranged. So really what we're saying is how many different ways are there of deranging 2 things? And we've already seen that it's equal to 1. So therefore, presumably we're going to do 10 times 1 equals 10. And again, this is the benefit here of knowing some derangements from the top of your head, which I said at the start of this. Consider instead the case of 3 letters, A, B, and C, placed in envelopes. Okay. 3 letters, A, B, and C, placed into, write down all the arrangements in which none of these letters is in the correct place. All right, we've got A, B, C only this time. We've got 3 letters. So I suppose A, B, C is a good place. They are all in the right place. But did we do one of these before? B, A, C would also be, well, that's no good because the C is good. So which ones are we talking? We're talking, I suppose, if the B starts, it's got to go B, C, A. If the C starts, the B can't be in the middle, so it's got to be CAB. I think there are 2 ways of doing this. And it says write them down, not just how many, it says write them down. So there, I think the answer is 2. BCA and CAB. Hence or otherwise, find the number of arrangements of the 5 letters in which exactly 2 letters are placed in the correct envelope. All right, so this is similar to what we did before, I think. But now we've got 5. That was 5C3 because we had 3 correct. So now I think I'm going to do 5C2. And 5C2 is 10. But that leaves 3 which are wrong. And they got to be wrong. So really, I suppose we're saying, what's D3? And D3, I suppose I should go back and check. D3 is, where is it? D3 is 2. I actually circled it a bit before when I did that. So we can now, oops, there it is. D3 is 2. So I think this is 10 times 2, which is 20. And I think that's the right answer. Let's see. Yes, I've got 20 there. So look, that's derangements for you. So we've gone through a variety of questions. We've seen an exam question. We've seen a couple of made-up examples, which I made up. And I'm hoping they kind of now make sense. So just remember the definition here. Derangement is where none of the original items are in the correct place. And hopefully you got to spot them. But don't forget, please, that some derangements we should know. So D4 was 9, for instance. use that to your advantage. All the best. Good luck in your exams.